All right, good afternoon, everybody. And this will be our second last regular Q&A session for the lecture material. Uh, your lecture 12, the last one, will be released around next Wednesday, as usual, following the usual schedule. And I think I will try to schedule maybe some extra Q&As, maybe to help you get prepared for the exam. I think we can talk about it later. You can expect to receive some e-class survey from me just to see which time might work better for you. But we can wait for that. We still have time. I think our exam is pretty late in the exam period. It's actually April 26th, I believe. So I think after the last day of the class, after your assignment 3 is due, you still got about 10 days or so to actually get prepared for the exam, or more than that, right? Actually, more than that, because the last day to submit your work will be 11th of April. So you got 15 days after that. But I'm pretty sure you got other things to worry about. But at least for this course, I think after all the regular lectures, we can still hold maybe 1 or 2 extra Q&A session to answer your questions. That'll be the plan. But anyway, I'll keep you posted. And let me talk about other announcement. We just released lecture week number 11. That'll be the second last lecture, the pre-recorded videos. And I would say really enjoy this particular lecture, because I think this one here really helps you understand about how to put everything related to binary search tree together, especially how we can make sure the running time for searching is guaranteed to be log n, the worst case. And the way to do it is by doing something called rotations. And we wouldn't focus so much on the Java programming this time, but at least we can actually talk about how you can do some conceptual and also visual illustration about how the rotations can be done. So that means you really want to practice about how to draw the tree rotations, at least to the standard, which I demonstrated in the lecture videos. You will see what I mean when you get there. I want to show you, just give you a feel. Of course, it was only released a few hours ago. I definitely wouldn't expect you to have a look at that already. Let me show to you. If you go to the lectures page and then go to week 11, and then I also got some exercises over here about the tree rotations for you. You'll see exactly how to tackle them once you follow the lecture. This will be something that you will be expected to know how to do. So given some question over here, and these are kind of the tree rotations annotation you will have to do, maybe in the exam. I can talk a little bit more about the exam maybe later, but really pay attention to exactly how things are to be done, and reach out to me for questions about tree rotations. I also make some high-level remarks about how you may actually implement each individual tree rotations by setting the parent-child references. Also pay attention to what I said verbally in the lecture, especially the final part. We wouldn't focus too much about the programming for this aspect for the data structure, but it's also very important for you to know. The implementation itself is not very complicated. You don't even need a loop for each individual rotation. You just have to set up the references for the parent and child accordingly. But it's more important to see how things will actually work visually. I think that's more important to achieve. All right. Anyway, so we'll discuss about this week number 11 lecture next Wednesday and Thursday as well, if you have extra questions. There is still about 30 minutes of lecture that's to be posted. I really want to hopefully finish deriving the running time for the merge sort, which I talked about in week number 10. And also, I want to move on to the next sorting algorithm, which is called quicksort, as an intermediate example for the recursion. But I think one of your Google Doc questions about how to understand about the various classes I gave to you about the sorting. I'll talk about it as well. So that will definitely help you understand the stuff. Right. Anyway, so that's where we are for the weekly lecture. And for your assignment number 3, it's already released on Monday. And just notice that the deadline I put on the instruction PDF is really the latest day I can push forward. Otherwise, beyond that, we are not allowed to actually submit any work for grading. And your programming test number 2 is going to take place next Monday and Tuesday. As usual, you can take your test on either Monday or the Tuesday, right? We have done this many times, so there will be no surprise to the format and the time. And the guide and the example questions have been released already. Actually, we're going to talk about one of the example questions I made available to you. That one is somehow related to what's being asked on the Google Doc. And for your programming test 1 grades, unfortunately, it's still being processed. I'm hoping to really release them when they are ready. I'm hoping that maybe either by the end of the coming Friday or early Monday. That's what I will try. Right? It's something to be done for programming test 1. But if you actually got any question about how to implement maybe your assigned programming test 1 questions, reach out to me. I still got office hour tomorrow. Just come to me. All right. Anyway, so that's about the course so far. Do you guys have any questions first before I dive into the technical questions? Anyone? You can feel free. Put on the chat or open your mic if you want to ask questions. Anyone? All right. Hearing none, seeing none. This is everybody is good. All right. Let's now move on to the Google Doc. Oh. Will we end up covering heaps? Indeed. So I think the heap data structure, to be more precise, we're going to cover about priority queue, heap sort, and also how you can use array to represent tree. They will all be in lecture 5D, which will be covered in the final one. Yes, we will be. I think the final topics to be covered will be, we want to cover what I just mentioned about heaps, and also I want to finish also the topic about hash table. I think that's also important. And as for the graphs, I thought maybe we will be able to actually cover at least the basics for the graph, but I don't think we'll have time. But that's okay, because normally the instructor from 3101, they will actually cover the graph data structure from scratch anyway. So that sometimes they even advise us that in 2011 we can cover other more topics in depth rather than just covering too much about graph, which will be duplicated. All right, so yeah, we're going to see heaps in the final week's lecture. Yes. Any other questions? Anyone? Alrighty, so let's now move on to the Google Doc question. We got 4 in total. Okay, two of them are more related to conceptual clarification, and the other 2 more about programming. Well, we will cover one by one. The first one here is actually more about clarification for the written test number 2. Right, so here, I think your fellow student wrote something over here. I think that what they wrote there was correct. However, let's just look at what they're trying to, what they need to, the clarification about. Let's try to read it together. That's one of the options in the written test. The extension of the previous reference in a doubly linked node is meant for improving the running performance of some singly linkless operation. And this is actually correct, the description. First of all, specifically, when we say some singly linkless operation, we are talking about remove last specifically. Right? Remember, if you only got a singly linked list, and if you, in order for you to implement a remove last, you have to get node at, which will take a linear time. Right? But if you actually got a previous reference, you can improve it to be constant amount of time. Right? That's something we said in the lecture. So this explanation there is actually correct. Right? So I believe the reason that your fellow student choosing this option here being deducted marks is because the question asked them to actually choose the incorrect answer, not the correct answer. So that's why this one here should not be chosen. Right? So if you're here, I'm just telling you, I think what you're describing over here is actually correct, right? But the question itself may be asking you to choose the incorrect answers. So that's why this correct description should not be chosen. Right? That's my quick clarification. Any follow-up to this? Anyone? If you have any other doubts about some questions or answers about the written test, feel free to drop by my office hour. I'll be more than happy to cover them. Any follow-up to this? If no, then we're going to move on to the next part. Everybody's okay? Alrighty. The next one. The next one here is about deletion from a binary search tree. And specifically, your fellow student was wondering about some, over here, about the exercise I put on slide 19 of the binary search tree lecture. But I already took a snapshot. It's mainly over here. We talk about 4 different cases for deleting a node from a binary search tree. And for case 4 specifically, when both of the node to be removed, if their children are both internal, so that'll be the case to handle. I'm assuming that you have already studied this part of the lecture, so I'll go directly to the point. Okay, and there is certain exercise over here, right? Let me just tell you what we said up to here. Just a quick recap. Let's say we want to remove the node 88. Let's say that's what we want to do, right? And of course, as part of the deletion process, we have to search where the node is to delete. So we're going to go 44, go to the right, and 88, well, exactly over here. So this is the node to remove, right? We want to remove it. And we said that we actually have to somehow replace the key value over here by the largest key value that's smaller than that, right? That's something we said in the lecture. And the way to find it out is to go to the left subtree over here, because we know that every key value in the left subtree is guaranteed to be smaller than this key value. That's the so-called search property. Out of those values that are less than the 88, we want to find out the maximum. The maximum will be the rightmost internal over here. So this is guaranteed to be the largest one that is smaller than that. More precisely, this will be the node that will come right before 88 if we try to do some in-order traversal, right? So these are all the insights we went over in the lecture. Let me write it down quickly. And if you have any doubts about what I just mentioned about the insights, I think you should really go back to the lecture and make sure you actually got those insights. We know that this is the left subtree. According to the search property, every key value there should be strictly smaller than that. But in order to find out the maximum value in this subtree over here, we should just keep going to the right, because every time we go to the right, we are finding some key that's strictly larger, right? So this will be the largest one. So this is the value that is actually, let me write it down. This will be the maximum value that is smaller than 88, right? And the exercise over there, let me just say one more thing before I go on. Let's think about the in-order traversal. How is it going to look like? Can we just do this in-order traversal over here? Just this part over here, right? Let's not worry about this part. This part is not going to be impacted by the deletion. Let's do the in-order traversal over here. I'm sure you know how to do in-order traversal. Let's see here. We got 54, 65, and then we got 76, and then 82. Sorry, 76, and then 80, and then 82, and then after that 88, and then 93, and then 97, right? So this part over here, let me see, this is the node we want to remove, 88. This is the left subtree, the in-order traversal on the left subtree, of 88. And this part over here is the right subtree. We also cover about the insight to really see the correspondence between the linear sequence versus the nonlinear structure in the lecture. So you want to make sure you also study that carefully. Right subtree of 88. And the 82 over here is really the maximum value. Let me use a different color here. The 82 over here is really the maximum value that is actually smaller than 88, right? If you put it in the linear way, it's actually easier to see. On the other hand, the exercise suggested, can we actually try to replace this value over here rather than just replacing it by 82, which we said in the lecture. If you try to remove 88 and you replace it by 82, it will be okay, because the resulting sequence will still be sorted. So that's okay, right? That's what we said in the lecture. But the exercise was really about symmetrically, can we replace the remove node over here? Let me just undo. Can we replace this node to be removed by maybe excuse me. Can we replace this node over here by the smallest key that's larger than that? Kind of symmetrical, right? Rather than the largest key that's smaller than that, we want to find the smallest key that's larger than that. That's kind of symmetric. The answer is yes, we can. Okay, let me show you how to do that. You can see from the sequence over here, the right subtree got all the keys that's strictly larger than 88. So if you want to remove 88, it would be fine if you also try to replace the 88 by the smallest value, key value that is larger than that. That would be fine too, because after the replacement, and I'll show you in the tree as well. After this replacement over here, you will still get 93 that goes after 82, so it's still sorted. Okay, so let's now see this. So that's really what the exercise is about. So this is the right subtree, for which we know every key value in the right subtree is strictly larger than 88. And in this case, we can actually choose the leftmost internal nodes over here. And that one there is guaranteed to be the minimum value that's actually larger than 88. So that'd be okay too. So you can also replace it by that. But of course, you got to be consistent. If you want to implement this in Java, either you choose to replace the 88 by what immediately goes before that, or replace it by what immediately goes after that. And of course, let's say if you chose this way here, if you want to replace 93 over for 88, let's say if you want to do that. If you do that over here, like what we said in the lecture, you have to delete this node as well. I want to think about what case this is. It looks to me this is case number 2, because you can see both child nodes over here are internal, right? Let me also make a note over here. If you want to remove it eventually, that one is going to be case 2. All right. Any follow-up to this question here? I hope that's clear about the insights that we actually went over in the lecture. Any question to this? Anybody? Since the exam will be in person, so it's going to be a paper exam, so you should really expect, well, you know, unlike the online exam, usually it may be mostly multiple choice. I think for the in-person exam, you will definitely be expected to justify, you know, about various things. So I think when you go over the lecture video, you really want to make sure you understand about the insight, which I went over with you visually. I think those will actually help you answer the questions in the exam. All right, any follow-up before I move on? Everything's clear? Alrighty, move on to the next one. The next one here is about how we can do in order traversal. So I think that's where the question was asked about how to implement it. I think rather than doing in order traversal, which you should really do as an exercise, I think this is somehow relevant to one of the example questions I made available to you for your programming test number 2. So I would suggest that we go over the solution to that particular question there, and then I will make this source code available to you. It's a valid Java code which I just took a snapshot from my computer, and then you can definitely still try to do the example test for that question there, and then you can compare your solution with mine later. I think that will work. All right. Let me just go over it with you very quickly. So what we have is we have a method called get preorder sequence. Right, that's a method. And oh, by the way, so we are now in the context of tree utilities, right? So that means we have to really program each method in isolation. You cannot really create any extra classes. So we got a method, and we want to get preorder. So once you understand this one here, adapting it to be in order should be rather straightforward, right? The input is going to be the root of some tree, and that's of tree node class. And also the return type is going to be a chain of singly linked node. And think about every singly linked node has its element being a tree node. Okay, so there's something I may just want to help you clarify a little bit over here. When you see this particular type, what does it really mean at the runtime, right? Over here, that's something you should also go over the test general trees .java, which I made available to you, right? You should also go over them. Otherwise, it would be difficult for you to see how the two classes work together. So what we got is, you can think about, visually speaking, we have at the top level singly linked node, and then one of its attribute is elements. Okay, I'll just say E for short. Okay, of course, we also got next. So this will be the next, which might be pointing to another node. I'll say dot, dot, dot. Okay, I want to show you the structure for a singly linked node. And according to the generics, you can see this part over here, tree node of E. So this will be the elements for each node. You can think about this part here, tree node of E over here. So this will be the elements of each node. Right? How do we visualize it? It's going to be something like this. So the element is actually going to point to a tree node. And if you recall the detail about each tree node class, and we definitely got some reference for the parents, and also we got the head and tail for the child nodes, right? So I'll just put the head node for the child, okay? And this one over here is simply just going to point to the beginning of the child nodes, right? So that's kind of the runtime structure you want to visualize yourself. And when you actually go to, let me just give you one more reference there, which we already gave to you for assignment number 2. Test general trees.java. You want to make sure you understand how the two classes work together, right? In order for you to complete the assignments and also to do the programming test, and of course the exam. Don't be too surprised if I ask you questions related to these two classes, right? Do you guys got any general question about these two classes? Any part that's kind of confusing to you? Now it might be the time to ask. All right. All right. That's okay for now. Okay, let's now go over quickly the way we implement the get pre-order sequence. It's going to be recursive. This one over here. Okay, let's see how we do that. First of all, this will be the resulting sequence to return. You can see the resulting sequence is simply the head to some singly linked node. Every node stores a tree node. Every tree node stores some element E, and E can be instantiated by maybe string, integer, or any other class, right? About generics. And we say that the result initially only is going to store the root over here, right? You think it this way. If I have a tree like this, if I have root, let's say over here, this is what's being given as the parameter or arguments. And we know that the root over here is actually going to have arbitrarily many child nodes. So according to the pre-order traversal, we have to put the root, first of all, into the sequence. And then we have to do the pre-order sequence on each of the child nodes, and then append them into the sequence, right? If you refer to how we visually illustrated the various traversal mechanism, that's actually how we did it, right? So that's why we simply put the root into the sequence first. And then we're given that if, put it this way, if the root.getChildren is simply equal to null, in that way, we're going to bypass everything over here. And we're simply just going to return the result, which only contains the root, which makes sense. If there's simply no child nodes for the root, you simply don't need to do any further recursion. On the other hand, if the root actually has some child nodes, in that case, we're going to execute this part here. And what is that? We're simply going to get, first of all, the children of the root, and then we're going to run a loop because the child nodes are stored in a link, like a chain of singly linked node. That's why we have to use our normal pattern to actually go over the child nodes one by one. For every child nodes, we are going to actually call the get pre-order sequence over here. So this will be where the recursion comes from. Okay, so this part over here, you can see we're calling get pre-order sequence, which is the method we're defining over here. So this part over here is worth noting. Get the pre-order sequence of a child. Once you get a sequence, you're going to insert it to the end of the result. So the add last over here is some helper method which I define over here. I'll show to you very quickly. That one is very straightforward to define. Right, and then this one here, I simply call it add last. If I got a head to some chain of nodes, I want to insert another chain of nodes at the end. the way to do it is I simply just use a loop to go all the way to the end until the current node that get next is equal to null. So that means I'm basically at the tail position for the chain. And then I'm simply going to set the next of the tail to be the list I want to insert it. Right? So that's I think this is really a critical step for you to actually see. And you can easily adapt this into post order or in order. Let me just highlight it over here. Right? So this is the critical line for you to see. All right. Any question about this implementation over here? Any question? Anyone? Any follow-up to this?
I have a question, sir.
Question? Yeah, go ahead, please.
I was doing something very similar for getting descendants off a root, but I wanted to do it with a linked list, not with an array. You see how we have add last and you pass result in it, right?
Yeah.
Because of the problem I was having is because of call by value. When I passed result in the parameter of add last, for example, head. It would create like a new copy, right? Because of call by value.
Yeah.
Then once you make changes to the chain, for example, you say current dot sit next.
Yeah.
And it will not be effective. It was not effective to the result. So when you return result, nothing has been changed because of the call by value, and you know, because the changes that you made was local to the function.
Yeah. So I think you should be okay. I guess maybe it's really the way you actually did it. I'm just taking a guess. But Adnan, maybe also bring your source code maybe to me in the office hour tomorrow. We can take a look as well. Let me just address this in a more general way. I think call by value, as you mentioned, is very important. Okay, let me just say this. Okay. It's good to recap very quickly about call by value. Okay, over here. And let me be a little bit more general. It doesn't have to be a chain, the head of some singly linked list. It can be any objects. So let's say if we have some method over here, let's say void, and then some method over here, and let's say we have some object. I'll just say objects over here, just some very general mechanism. And then let's say this is the result that you were talking about over here, and then we may have other things over here, right? Let's say this is kind of our recursive helper method, and in which you're expecting to really modify the same object every time so that the same result can be accumulated somehow. That's really what we want to achieve. Let me show you two different ways to do it, right? Approach number one, if somehow you actually got result, maybe it's reassigned to something over here. Very general, just try to reassign that. That's approach number one. Approach number two is when you say result over here, maybe that set, maybe some mutated method you want to call. Maybe say set elements, just for illustration. Set element over here. Okay. And of course, presumably you're going to pass the same reference as the result for every recursive call. That's really the key. Okay. Let me show to you why number one over here is not going to modify the objects. But number two is going to. So Adnan, if you somehow thought you were doing number two, but you're not really modifying the original object, so there may be some minor detail in your code that actually make this happen. I need to take a look. But if you were doing something like this, then that might be the reason why the global structure was not modified.
Oh, actually, yeah, I just recall from last year, from 2030, that you did something similar when you do void. Yeah, mutator method was changed. Yes.
Yeah. So let me go a little bit further with this, but still bring your code to me if you want me to take a look. I think if you were trying to do something like this, I think that's understandable. It's a very common misconception because you thought that you're simply just trying to reassign the result to be something else. So that one should really be modifying whatever the caller is really passing, but it's not the case. Let me tell you why. Okay. Let's say this. Let's talk about scenario number one and scenario number two. Right? It's more like a review about the callback value that we learned from 2030. For scenario number one over here, let me say I got I should say objects over here result. Let me use a different one. let me say X. So we got different name. So you wouldn't get so confused which one I'm talking about. Let's say X. Let's say X is simply initialized to be some objects. So X is really pointing to some object structure somewhere in the memory, right? Whatever type it is, doesn't matter. Okay, of course, we got some attribute value over here. Let's say one of the attribute is about Y. So what we want to do is maybe we want to modify the Y value for this particular X object. Let's say that's what we want to do. Okay. And for approach number 1, let's say this is how we call the method. Let's say we're trying to call the method in this way. If we say M, and then we say X with other value over here. Okay. If you're trying to do something like this, what's happening over here is because the call by value, the result is actually going to store the same address that's actually stored in the arguments, meaning that we're going to have the following aliasing scenario. So we're going to have result is actually pointing to the same objects. Because the call by value, the result over here in the method parameter and also the arguments X over here from the caller, they are pointing to the same objects over here. So once you have this visualization here, you would know why having this is not going to help you. Let's see why. If you try to execute this method over here, if you try to say result is simply assigned to over here, so that means you're trying to say result rather than pointing to the original object here, is actually going to point to somewhere else in the memory. In this way, you're not really modifying X because X is still pointing to this original objects. That's scenario number 1, which doesn't work. If we try to do scenario number 2, let me just cover that quickly. Let's say star star, and then we still got objects X is equal to over here, and then we still got our X pointing to this particular object over here, and then we still got, let's say, Y attribute that we want to modify, right? Let's say. So when we call this method here, let me use m.x, m with x being the arguments. And as we said before, when you're trying to call the method over here, result is also going to point to the same objects, which would be over here. And the way we do this one here is to say result.setElements. In that way, when you say result.setElement is actually going to change the Y value over here. So we are really modifying the object that's also being pointed to by X. So this is the way to use the callback value in the recursive call. So Edwin, is that kind of clear to you about what's happening here?
The first thing was exactly what I was doing, yeah.
Okay, good. Okay, good guess. Okay, awesome. Yeah, you really want to avoid that. It's really important to avoid it.
Thank you so much, sir.
No problem. I think what Adnan was just posing over here is a very common mistake you want to avoid. Hopefully, well, I think in the case of 2030, we couldn't really give you very complicated example to explain about the callback value because you didn't learn about data structure at that point. But now, since you have to use callback value so often, for example, what we are doing here, the result being passed over here is indeed exploiting callback value. So you definitely want to avoid what Adnan would say. So I think that's good. Yeah. Alrighty. All right, guys. Any follow up to this? Another way I would like to put this course, to say this course is definitely teaching you lots of exciting data structure. But I would say in some way, think about this course is more like the other half of the story about OOP. We learn about many advanced techniques like inheritance, callback value, aggregation, composition in 2030. But we couldn't really give you very complicated example. But in 2011, you definitely get much more sophisticated example like a tree, stack, linked list, in which case you have to make sure you still understand the principle that's covered in 2030, right? You really want to put these two courses together. So for those of you who may not be taking a new course in the summer, I would suggest you may just want to maybe go back to your course materials, labs, whatever material you got for 2030 and 2011, just make sure you review them before you get on to the third year. I think 3101 usually wouldn't require much about programming. It's more about conceptual sketch of the algorithm. But I think once you get to maybe software design, or maybe other courses, you wouldn't really go beyond what you were taught in 2011 and 2030. I think that these two are really the foundational courses you want to make sure you review before you go on to the third year, right? Already, one more call. Any more follow-up to this? Right, so it will be now up to you to really do the example test for programming test number 2. And then you guys are going to maybe review these two, maybe after you have done your attempt, and then compare them. Okay, feel free to reuse the code over here. That's okay, since I made it available to you guys. Right, from Adnan, am I going to teach the software design this fall or winter? I don't know yet, actually. But for you guys, if you're really interested taking another course with me, in case, okay, I can mention that. It's very likely I might be teaching a 4th year course, but I believe for you to take that one, you don't really need the prerequisite on the 3rd year. In that case, you can think about EECS2011. This is a course called Compilers and Interpreters. That one there will definitely train you about doing a large project, about defining your own compiler. Okay, but for you guys, if you happen that you don't really satisfy certain prerequisite for this course, it's okay. I'm going to teach this course on a regular basis, usually in the fall. So if you don't see me in the coming fall, maybe when you get to your 4th year, take this course with me. That course is not really required for CS, which is a shame, I believe. But I think it's a very good course for you to know how to build your own compiler, which is rather cool to put on your CV as well, right? If you're really interested in seeing what exactly that's being covered there, let me show to you, right? Just out of your interest. Okay, very quick question here. Will the tree on programming test 2 be binary search tree or another tree where the ordering of the descendant be I think it's more the latter. I think for your programming test number 2, we're still talking about general tree. If you really have to assume a particular order for the tree child nodes, I'll let you know explicitly, for sure. But I think you can just assume, if I didn't say anything like that, it's just going to be general tree. All right, guys, very quickly. Wouldn't take you too long. I just want to show to you. If you guys are wondering about what compiler is, that's something I'll mention in 2011 anyway, after I finish the topic next week. If you guys go to 4302 over here, and don't worry about the stuff over here. You don't need to do anything with it. There is one tutorial video which I created when I taught that course. And this one here, for those of you who may want to do something for fun over the summer, and maybe once you completed this little project, you can feel free to put on your GitHub as well. I think that might be a nice little compiler you can build from scratch. It was more like a self-contained tutorial video about how you can build your compiler implemented in Java. And to really build a compiler, recursion is the first class citizen to really get understood. So what Adnan just talked about call by value and also recursive call, everything that we covered in 2011 can be nicely exercised in this course. So that's why I said every CS student, to my opinion, they should really take a compiler course. Anyway, so if you guys want to take a course with me later, 4302 could be a good one. All right. Yeah. I think for many of you guys who took a 1st year or 2nd year course with me, we haven't really seen each other in person. So once we return, we already returned back in person. I think you might see me in the exam room anyway. So, but maybe later once we get to the 3rd year, come back to say hi, right? But you will see me in the exam room anyway. Okay, good. All right, sorry. Let me just go back to where we were. Somehow I lost it. Sorry. There we go. Already. All right, guys, the final question over here. The final question over here is interesting. Okay, I can tell you that this one here is somehow, I didn't quite mention that because I was wondering if the class, or at least one of you guys might be interested in figuring out exactly what's going on over there. This, let me tell you what's happening here. Right? Let me just change the, let me show you exactly. I want you to gain something from this particular lecture. Give me a moment. By the way, for those of you who are using a Mac computer, so they recently introduced something called universal control. It's a really cool feature, but you gotta be careful. Sometimes you don't really want your cursor to be on an iPad, and sometimes you really want it to be on a computer, but it wouldn't listen to you. Anyway, for those of you who use Mac, you might know what I'm talking about. All right, so let me just change my workspace. I want to show you exactly, this will be the last question, right? So I will keep it short. Oh, Ednan, you asked a question. Awesome. I'm glad. I'm very glad. I think curiosity is always important. Let me just go to the lectures. Okay, good. I think I'll try to give you some perspective about why this nice little source code project for sorter is actually important. Okay. First of all, let me mention the question. In your example code for lecture 4, recursion, you will see under example recursion, you will see many classes over there. You can see under the sorters, somehow weirdly, very weird, we got an abstract class called sorter. And the only, this one you might be able to understand because we say sorter is simply an interface, and we simply define the header of the sort method. This somehow corresponds to what we learned in 2030. You simply want to define the interface for some application, and then you may have multiple implementation. In this case, either you can implement the sorter using the merge sort algorithm, which you already went over in the lecture. And hopefully this week, I'm also going to cover how you can implement alternatively using the merge, the quick sort algorithm, right? So I think that the architecture so far over here is understandable. You got the interface. Let me show to you. You actually got the interface sorter, which defines the header for the sort method. You got two implementing classes. One is the merge sorter, and the other one is a quick sorter. And each one of them is going to implement the sort differently, right? So far, hopefully that's making sense. But the problem is, why do we have so many classes over here on the testing side? That's really the question, right? Let me show to you what's going on over here. And I'll try to use the debugger to show to you exactly what's going on. This little case study here can help you understand further about polymorphism and dynamic binding, which we learned in 2030. I'll show to you briefly how. If you look at the classes over here, let me show to you the relevant one. The test sorter, test merge sort, and also test quick sort, right? Thinking this way, if I tell you that I want, let's say we got two algorithms, merge sort and also quick sort. I want you to write test cases for them because they're both sorting algorithm. So for every input list, let's say empty list, you will have to make sure you test the empty list for merge sort. You also need to test the same list for quick sort. So in some way, testing, you have to write two test cases. One will be the empty list on the merge sort. The other one will be the empty list on the quick sort. But isn't that like a duplicated code? So that's not really good. So what we want to improve is we can somehow use the inheritance structure on the testing classes side to really make sure we only we can minimize the code duplicates, right? I want to put it a little bit softly. And this is one of the design patterns which you might learn in the later 3311, the software design course. It's something called factory method design pattern. If you guys are interested, feel free to Google that. You can definitely find more information, but I'll give you a feel about what it is like. It's called the factory method design pattern. It's a very handy and very common one. And every time if you encounter the buzzword design pattern in the context of OOP, is mainly about polymorphism and dynamic binding, right? That's something you will see maybe in your 3311, the software design course. Right? Let me just give you some idea about exactly what's going on. But before that, let me now try to show to you some classes over here. So if you look at the test sorter over here, so this class over here is abstract, meaning that it's not directly executable. Only non-abstract classes are executable, number one. And we have an abstract method over here. You can see that one there is returning the type sorter. And remember, sorter is the interface. Dynamically, it can be either merge sorter or quick sorter. Keep that in mind. And we don't really supply any implementation over here. So this is only just a method that is going to return some type whose static type is sorter. Okay, let's keep that in mind. This is really wonderful. You can see here, this is one test case over here. The test sorter empty list is really supposed to test whether or not your algorithm for sorting is going to work on an empty list. Since we got two sorting algorithm, does that mean we have to repeat the same block of code twice? Not necessarily, because of the magic over here. You can see here, this line here is really critical. When we say sorter is assigned to some sorter, right? I want you to focus on this. This is actually a return value from this abstract method, which statically is only sorter. Dynamically, it can be either merge sorter or quick sorter. Because of this, we only have to write this block of code just once. That's all I need to say. And after that, once you get a sorter over here, all you gotta do is just to make sure once you've done the sorting, the sorted list that's returned is simply just empty. Two more things to show to you, and then I'll get to iPad, make some annotation. Don't feel too bad, guys, if you kind of feel lost. This is kind of like a sophisticated design pattern, but I think you deserve to know since you're getting to third year very soon. Let me just show you one more thing here. If you get to the test merge sorter here, you can see this class over here extends the test sorter. What does that mean? That means it's going to extend everything we got over here in the test sorter, including the abstract method over here. But remember, in order for your method to extend an abstract class, you must implement all the inherited abstract method, including this one over here. So you can see the only thing we do is to implement the sum sorter over here. All we say is you're going to return the new objects dynamically merge sort. Symmetrically, if you go to test quick sorter over here, in that case, you're going to return quick sorter. That's all we're going to do. And why is this magical? Let me show to you a bit. All right, you kind of get some big picture about the architecture over here. Let me just give you some idea over here. You can see we got test sorter for which is abstract. We got merge sorter, test merge sorter over here extends from that. And also we got test quick sorter also extend from that. And here let's see what's going to happen over here. At the runtime, what we're going to do is we're going to run the test sorter actually twice. Okay, so at the runtime, the test sorter, let's say this particular method over here is going to be run twice. But how exactly? It is because and notice that this particular test merge sorter, that one is not abstract, so we can execute it. Okay, let's say when executing, let's say this one over here, right? Test merge sorter. When we do that, we're going to run the test case one by one. Remember, all the test cases, including this method over here, is inherited to this particular class, right? So this method over here is actually inherited to this class because it's being extended by the merge sorter. Is inherited. And that one there is really expecting the return value from some sorter. Some sorter at the level of test sorter is abstract. However, at this level over here, when we try to call this test sorter over here, that one there is returning merge sorter. Right? At this level, the dynamic type of some sorter is merge sorter. Okay, that's dynamically. When executing this, the sum sorter returns merge sorter. Meaning that once we return the merge sorter over here at this level, once we get that, when you try to call sorter.sort, it is going to call the merge sort. Similarly, when you try to execute this particular class over here, the same method over here is also inherited to this class over here. However, you can see the way we implement some sorter over here is by returning a different dynamic type, which is quick sorter. Meaning that when we try to call the method over here, sorter.sort, is going to dynamically call the merge sort instead. That's kind of how things are going to work. And then, do you kind of get an idea somehow? Maybe somehow.
Yes, I certainly feel better.
Feel better? Okay, don't worry. No, it's and let me just do one more thing. I can maybe do a little bit better maybe next time. But I think at least you got some. But let me just show you one more thing on the Eclipse. This is a design pattern which you will learn in 3311. So guys, don't feel bad if you don't quite get it. But at least I will encourage you guys to, based on what I explained up to now, maybe try to see if you can make more sense from the classes that's given based on what you learned in 2030. I want to show you one more thing, which is rather cool. This one might help you further. Right, go back to this. Let me use Eclipse to help you further. If I go to over here, test all, right? If you look at test all over here, we are saying that we're going to call the test merge sorter followed by test quick sorter over here. And then what I will do is I'm going to set some breakpoint. If I go to test merge sorter, this one is going to return merge sorter, right? And also, if I go to test quick sorter, that one is going to return different dynamic type. So far, so good. What I want to set a breakpoint is over here. Go to the test sorter over here. This is where the templates of all the test cases are defined. I'm going to, I already did, put a breakpoint over here, right at this line over here. What you will see is, at the runtime, we're going to call this particular method twice. How? The first time, let me give you some look ahead. The first time this block of code is going to be called is because we try to execute the test merge sorter over here. That's the first time. And the second time it will be called is when we try to call the test quick sorter. That's the second time. Let's see exactly what's going to happen. Each time it is called, once the some sorter has returned its value and we store that into sorter, we're going to see how dynamic binding is going to work differently. Let me just illustrate it to you. Okay. Let me launch the debugger. Just make sure you put a breakpoint in line number 20 around here. And then I'm going to launch the debugger. Okay, let's now switch. So now this is the first time, right? I want you to look at the stack trace a bit over here. You can see at the moment we are executing the class test merge sorter, right? And then if you try to look at the sound sorter over here, this one over here is actually going to return to you dynamically a merge sorter. So if I just say step over here, if you just move your mouse over sorter, you can see it's a merge sort, meaning that dynamically, when we call this sorter.sort, it is going to invoke the sort method that's implemented in the merge sorter. Let me show it to you. If you say step into, and we are now in the context of merge sorter, and this algorithm over here is about how we can perform merge sort, right? Up to now. And let me see how the same block of code can be executed, but it will use the quick sorter instead. Let's see. Don't stop, and then simply say step return. Okay, we're going to do a few. Step return. Step return. Step return. Step return. Yeah, we're going to expect a number of them. Okay, just keep doing. Okay, at some point, we'll go back to the same block of code in just a moment. Step return. Step return. Okay, almost there. All right, so now we are back to the same block of code over here. So that's the second time we're executing this same fragment of code. But now this time, if you look at the stack trace, now it is test quick sorter. That's the magic part. Because you can see it is the same block of code without being duplicated. So now if you actually try to do step over, you can now see that sorter now has a dynamic type quick sorter instead, rather than merge sorter. Right? So we are really executing the same block of code, but with different dynamic types. That's really what's happening over here. And then if you now try to step into this line over here, let's try to do that. That one there is actually going to sort, but using quicksort algorithm under the quicksorter class, right? That's basically what I want to demonstrate to you. This is actually quite a nice, very challenging, I know, that's okay, but we still got time until we actually have to say goodbye in the course, but you guys, you can feel free to study this a little bit further. Feel free to post out follow-up question on this on the Google Doc. I'll be more than happy to go over this again. This is some kind of the design pattern you will be expected to actually study in the third year software design course, at least if I were to teach it. Anyway, right? It's yeah, I think it's a nice challenge for you to think about. Not exactly about data structure, but it's more about the design of OOP. Yeah, sure. No problem. You know what? In terms of the design pattern over here, it's called factory method design pattern. Sarah, Miki, sorry. So it's called factory method design pattern. However, we didn't really cover this design pattern formally in the class. So, okay, in case you guys are panicking about how to understand this, let me say this. Number one, this particular pattern will not be covered in the exam or in the test. Right? That might give you a little bit of relief. On the other hand, I will really encourage you to really take a look at this kind of interesting. Okay, good. I would encourage you guys to really take a look at this kind of architecture of so many classes, how they actually work together. It's a very nice case study to really reinforce your understanding about polymorphism and dynamic binding, right? But try understanding it. As I said, for those of you who are really curious, feel free to put any follow-up confusion when you study this architecture over here on the Google Doc. I'll be more than happy to go over it again. I think it's a very cool architecture over here. Very handy. So these are from week number, yes, I think so. Okay, sorry, let me just go back here. I think it's mainly, Sarah, it's mainly about the source code from example recursion. I think the same source code has been made available to you. So I kind of just gave them to you without explaining them. So I think, yeah, you can look at the lecture themselves. Don't really explain the architecture. So that's why I want to go over that quickly in the Q&A. Yeah. All right. Oh. So guys, I think we have done everything that's put on the Google Doc. I really like the questions you guys posted. I think it's nice. But do you guys got any additional questions related to lecture? You can feel free to ask. We still got 20 minutes before the end of the session.
Oh, sir, can I ask another question?
Yeah,
about
of course.
Programming exam.
Yeah.
Unlike previous exam, the hint that you gave me really helped me to prepare for it. But this one, I'm not really sure, like what.
Oh, for the programming test,
practice.
Right? Okay, very good.
Yes, the programming exam too. I'm not really sure what to.
Yeah, I'll be more than happy to give you guys some hints about how to prepare that for sure. I think so for programming test 2. Let me think about what I can say. Okay, number 1. You will be given one to two methods to implement. I think 2 is more likely. Okay, and I think tentatively, one question will be close to the level of difficulty of the examples I gave to you. I think I gave to you two of them. One is the get pre-order sequence that we spoke about today. That one there, make sure you can do things like that. Definitely try to do post order, in order, and etc. And also the copy of method. That one basically just duplicating the tree. That one also nicely can illustrate how recursion works. I will actually maybe I can go over if you actually try to do your solution for the programming test, feel free to show to me your solution maybe tomorrow. I can also take a look, or Monday. And another question will be most likely about also recursion on tree. Okay, and of course the recursion on tree, and also you may also have to use the simply link node. That's basically the structure for your test. I think to really get prepared for these two over here, I think the hints I gave to you, if I remember correctly, was for you to look at the example you did earlier in the first year or second year in array and simply translate that into simply linked node. I think that's what I gave to you. But I think for this one here, you may just want to go to the link I gave to you on the leak code. Maybe try as many as you can, at least the easy ones and also medium one. You may not be able to solve every one of them because we don't have that much time before next week. Try to solve some of them. At least you should want to get used to about recursion on the trees. That's what I can say. But I would say this one over here will be slightly harder than this one over here. That's kind of what I can expect. I really want to give you guys something that's simple that you can program right away. But there will be another one that'll be more challenging to actually solve. The leak code link for recursion, let me show to you. One moment. If you guys go to 2011 and go under week number 10, the guide over here, and go to last page over here, right? There's a leak code link. All right, just go to the link, and then there are many problems over there. I don't think they necessarily give you the solution, but I think many of the problems over there, I think if you Google, for the solution, you might just be able to find some. So you can actually try to maybe study their solution and try to work on that on your own as well. I think that one can definitely help you solve some extra questions for sure. But I think also maybe study. So this one over here, I will have several suggestions over here. So one would be the leak code. And number two would be the assignment number 2 solution. Try to look at how I actually solve the problem. I think for both methods, I try to solve that in different ways. Try to see exactly what's being done over there and try to learn from them. And you might be given something that's slightly simplified. Of course, I wouldn't give you something that's as hard as the assignment itself, since you only got 65 minutes. So yeah, that's what I would suggest for the hints. Ednan, I hope that helped.
Yes, that helped. I have so many things to work on now.
Yeah, you got many things to work on. Good. That's really the main intention for some programming tests, so you can really push yourself. Do extra exercises. I think that's important. Yeah, for sure. All right. A quick question about the assignments for the first method. Sure. Should we assume that all the input lists are correct? Yes, indeed. I believe, Sarah, if you go to the comments for the method, I'm pretty sure one of the assumption is you can assume that the input list for the postfix notation is always valid. You don't need to do any error handling. So then we shouldn't worry about having, for example, only one. Yeah, you don't need to. You don't need to do any error handling, as we said in the lecture, just to simplify the matter for you. No problem. Good. Awesome. Yeah. Yeah, I believe for both methods, you definitely can assume the input list of the postfix notation, they are simply just valid. We wouldn't give you any input list that actually represent like an invalid postfix notation. We wouldn't do that. at least not for the assignments. All right, guys, any more questions? All right, so I think we still got one more regular Q&A next Thursday. And then, given that our exam is on April 26th, I think I might just give you guys a break, maybe on the week of the 11th of April. You may just want to catch up with other courses if you need to. And I would suggest maybe on the week of 18th of April, I think I'll try to do some survey, maybe later this week or early next week. I'll do that and to see which time slot you guys might prefer. And then we can actually talk about we can talk about the different questions you might have for the exam preparation. Okay. All right. From Sylvia, can I post answer to week 10's exercises? For BST insert and BST delete implementation. I think for those two, I'll really want you guys to really try to implement by yourself. I don't really have the solution myself, but I think the conceptual sketch I gave to you is very close to the actual solution. So I think maybe try to implement them. And if you really get stuck or you simply got some tentative solution, drop by my office hour. Doesn't need to be this week, can be next week, and I'll go over them with you. How about that? Sounds good. Awesome. Yeah. I think you'll be also similar for week 11 lecture. I think the big, we definitely got some visual exercises for you to draw some diagram about tree rotations. That's one part. But I think the other part would be, I think for your learning, I think later on, you might run, beyond this course, you might run into the need of implementing a balanced binary search tree from scratch yourself. I'm not sure why, but maybe that's the case. In that case, you will definitely need to know how to do rotations. So I would say when you still got access to my office hour, or still got access to my attention, why don't you guys try to also implement some simple rotations, so at least you can get some feedback from me during my office hour. So I think that might be something you want to do as well. Okay. All right, guys. Final call if you got any further questions. But we still definitely got next Wednesday, Thursday. But I think tomorrow I will still be standing by around 8:30. But if nobody show up tomorrow, then I will finish the session earlier. But otherwise, I'll see you guys next Wednesday for sure. Right. And for those of you who may want to participate in the course evaluation, please feel free. I mean, we still got a few days before the early participation deadline, right? Hopefully you guys will reach there, so I'll give you guys bonus point. Alrighty. Guys, thank you so much for coming, and I would say catch up with the lecture, and if you got any other questions, reach out to me, and then we'll talk. All right, guys, you take care. I'll talk to you very soon. Bye-bye.